Hi babies, it's been a while since I've made a video for you and I know you're feeling abandoned, but I promise you I have not abandoned you, and I told you I would definitely do the Unit 7 videos as well. These are just not required. So basically the AP board tells me things that I should be giving to you as assignments, and then after that what I want to do from there is up to me. But I do have to assign the Unit 7 things because a lot of classes around the US had not gotten to Unit 7, just like us. So they covered what they could quickly. All right, but now I'm going to do a video on differential equations as well. And this is based on my notes. And then after this one, I'm going to upload the test. And I'm gonna work through it like in a video, so you don't have to do any of that with me. You have finished all of the required videos, but I highly recommend that you work with me on those. So we're gonna do differential equations, growth and decay. All right. Okay, so let's just do an example, and hopefully you have watched those videos provided by AP College Board, and so now you have kind of an idea, and then we will do these together. All right, so the example is solve y prime equals 2x over y. All right, when you see the word solve, you know, before differential equations, you thought that solve just meant like get what x equals, like x equals 5 is to solve. That is true, but not when we're talking about a differential equation. This is a differential equation because of this dy dx right here. So when you solve, okay, if dy dx is there, then it means to find the original function y. Okay. All right, so for this one, first of all, I'm going to rewrite this as dy dx equals 2x over y, and this is because you're going to want to do a separation of variables. So your dx is going to come up here and your y is going to come up here. So we get y dy equals 2x dx. So basically all I did was cross multiply. So the y came up here and the dx went up there. Okay. And then I'm going to stick an integral symbol in front of it. You can't just have this hanging out by itself. You got to put that integral in there right away. All right. Because really what I'm doing is the antiderivative of this with respect to x. And so then my dx's would cancel, and then I'm doing the antiderivative of this with respect to y. Okay, so just make sure you put the integral symbols in there with your dy, and especially on this FRQ that you're going to be doing for the exam, because you don't have any multiple choice, so it does matter how your notation works. All right, now this is with respect to y, so this is the variable. So how do we do that? That's just the power rule. I'm going to add 1 and divide by it, so this is already a 1. So I get 1/2 y squared plus c equals, all right, and then add 1 x squared plus, okay, this is like a c1 and a c2. These are two different ones because I did an antiderivative on this side and I did an antiderivative on this side, but now you can just kind of collect them both. So I'm gonna multiply everything by 2. Well, I don't know, I don't think you would notice that, so let's just leave it. Just get them both on the same side. And there you go. That is a differential equation solved. Now, if you were asked what this is, I don't know if you would recognize it or not, but it is hyperbola. So that's like these two. It's an ellipse that's been cut and then flipped inside out. All right. Yeah, so that's it. You don't have to solve it for y. If you tried to solve this for y, you'd get a plus or minus the square root. And we don't want to do that because then you would have the plus or minus part. So if you can solve it for y, solve it for y. if it's not an even exponent. All right. So some wording that you might see when you're doing these is if they say that y is proportional, that the change of y. Okay, so if they say some wording to look out for. Okay, if they say that the rate of change of y is proportional to the value of y. That means that it's going to be, what you're going to write is dy dx, because that's the rate of change of y. That's that part. Is proportional to means equals, and then proportional to means like some kind of variable. I mean, so a times whatever comes next, okay? The value of y. So these are going to be, the value of y is going to be on the same level, because is proportional to means same level. If they say inversely proportional to, it means put it on the bottom instead of on the top, okay? So equals a is proportional to the value of y. All right. This is your growth constant. Actually, a lot of times they use k's. If you'll recognize it from pre-calculus where we did exponential growth and decays. These come out to be equals y equals ce to the kt. All right. So a lot of times they put a k here, but it really doesn't matter. All right. And then if they say is inversely proportional to, so if they say the rate of change of y is inversely proportional to the value of y. This means dy dx is a over y. See, inversely proportional to means a times and then the flip of it, okay? All right. So, yeah, okay. Let's do an example. The rate of change of y is proportional. Oh, and if they say is proportional to, this comes out to be y equals ce to the kt, or at is what I had there. So let's actually put an a to the at. Okay? So you can skip to that if you want to, but I would write this step first, probably, since we're doing an FRQ. All right. Is proportional to y when t equals 0, y equals 2. When t equals 2, y equals 4. What is the value of y when t equals 3? Okay, so I'm going to do dy dx equals ay. That's that first sentence. All right, and then I'm going to solve it for, like, I'm going to solve this a differential equation. So I'm going to put this over here. So that's dy over y equals a dx. Take the antiderivative of both sides. All right, so this is 1 over y dy. whose derivative is 1 over the variable? That's ln. So this is ln of the absolute value of y plus c1 equals, now this is just a constant, so that's just ax plus c2. Okay, and now we're going to absorb, and you're going to solve this one for y because it's not a square or a fourth or whatever, so you can solve this for y. So we're going to absorb that over here. So this is the ln of y equals ax plus c. Okay, and you don't have to do minus c, c1, c2 minus c1 is just some kind of constant, so that's how I'm doing it. I just move it over here and it just becomes one constant. All right. Now I'm going to raise both sides to the e. So my e would cancel here and I would just get y. Okay? Equals e. Now I can drop the absolute values because e to the anything is always positive. So that's why where the absolute values went. E to the ax plus c. All right, now this is where a lot of students get confused about how I get this formula right here. Okay, well, addition in exponents, let's just kind of buffer on the side. That's x to the 2 plus 3. That is x squared times x cubed, right? That's the rules of exponents, is that it's that. So we get y equals e to the ax times e to the c. All right, well, e to the c is just some other constant because that's just some number. Okay, so we just write it as one big C in front and then e to the ax, okay, or kx or kt. I mean, you got all kinds of choices here. And actually they said when t is 0, so I should have been using t's. They said t's and y's, and I did x's. Whoops. So because I'm on an FRQ on the exam, I'm going to go back, and that's annoying. But you're going to change every single one of those x's to a t so you don't lose points for something silly. Okay, so now I'm going to use this. And again, if you see this, the rate of change of y is proportional to y, write this, maybe write this, and then skip to that. Okay? All right, especially since you get all your notes on this. All right, now they say t is 0. Y is 2. Well, if you plug in 0, then this is 1. So I just get 2 is c. So now I have y equals 2e to the at. Okay. All right, now I'm going to have to flip the page, which is annoying. All right, so y equals 2e to the at. All right, now the next thing they tell me is that when t is 2, y is 4. So now I'm going to plug in 4. So 4 equals 2e to the a times 2. All right, divide both sides by 2. So 2 equals e to the 2a. Take the ln of both sides. And then divide, so I get 1/2 ln of 2 equals a. All right. And then usually you're going to use your calculator on these. If you can't use your calculator, then that's fine. You would just write this as a. So our new formula is y equals 2e to the 1/2 ln of 2t. Okay. All right, and then now it says, what is the value of y? So the question was, what is the value of y when t is 3? All right, then you just plug it in. So and then that's it. That's the answer. If you wanted to, you can grab a calculator. And you can put that in. 2e to the 0.5 ln of 2, close that parentheses, then times 3. And there you go. It's about 5.66. All right. Let's do another example. The rate of change of the grams of plutonium is proportional to the grams of plutonium. Okay, so the rate of change of y is proportional to y. Okay, so that just means straight up that we're going to write that dy dx equals a over y. I mean ay, and then that's going to be ce to the at. Okay, and then the half-life of plutonium is 24,360 years. Fascinating. Suppose 10 grams was released in the Chernobyl nuclear accident. How long will it take for there to be 1 gram present? Okay, this is actually a pre-cal problem if you don't do the differential equation part. So I'm going to fudge the differential equation part. dy dx equals ax. I mean ay. Okay, that's that sentence right there. And then I'm just going to show my separation of variables. So 1 over y dy, right? I just moved that over here, equals a dx. And then I get y equals ce to the a. And I used x's instead of t's, so I'm just going to do ce to the ax. All right. There's my calculus. Now I can just do what they did. Now I can just use what they did up here. Okay, so the half-life. Half-life just means, I mean, they could say triple life, they could say quarter life, just whatever. All that means is that this is t, this is how long it takes for it to be half the original amount. Okay? Time for half original amount. Okay. Now they also tell us that this was released in the beginning. So this is the original amount. So this right here is C. That's always your starting amount in this formula here. Okay, so now we have y equals 10 e to the ax. And then now x is time. So we're going to plug that in. And then that would be 5. So 5 equals 10 e to the 24,360 times a, right? Sorry, I flipped those. That should be, that's x, and then that's a. Okay? All right, and then, so that's half. And that's what's going to always happen when you do half-life, is you're going to get a half there. And then take the ln. And then divide. Now, if something's decaying, when you put this into your calculator, you should get a negative number. So this time I'm going to do that. And this is a model. This is what the model is called. So ln of 0.5 divided by 24,360. And I get, that's times 10 to the negative 5. So don't forget that. So a, now you do 4 decimal places in general on the AP exam. So negative 0 point, and then 1, 2, 3, 4, and then 2. So that's 1, 2, 3, 4, 5. Yeah, but I'm going to do like 4 digits, 4 numbers. 4, 2, 8, 4, 5. Okay, so my model, if you were asked to find a model, that's it, that y equals, make sure you pay attention to what letters they tell you to use. Like if they say P is population, then make sure you put P equals, okay? And then what is it? 10 e to the negative 0.000012342842845 x. Okay? And then they say, how long will it take for there to be 1 gram present? All right, so I just like to store this. Store as, and then I'm just going to use the letter, so alpha A. There. And now I can just put that in right there. All right, so then it says, how long will it take for it to be 1 gram? Well, you put 1 equals 10 e to the negative 2845 x, and then we're solving it for x. So 1/10 equals e to the negative 2845 x. Take the ln of 1/10. Divide by that. And so then x is approximately, and then I'm going to do ln of 1/10 divided by a. 80,000 years. 80,922.1684 years. So, as you can see from this, now you can see the issue with nuclear power plants, why some people are worried about them, because if you do have an issue, then it takes such a long time for radioactive material to reach a safe level to be inhabitable again. All right. Okay, I think that is enough of the examples. And then we will, in the next video, go through the test as a worksheet. So I'm going to put it online if you want to print it so that you can do problems with me. Then we're just going to like work a few at a time. All right, bye guys.